equation would be for these two? Well, the first step would be to write them in their factored form. If the answer is 3, what would I have had here? X minus 3. What would I have had here? X minus 5. Now, I can multiply that out and get a quadratic equation that has that as an answer. I multiply that out, x squared minus 8x plus 15 equals 0. There's a quadratic equation with that as an answer. That's 1. I could come up with an infinite number because I could put that in a parenthesis, and I could say, I could multiply it by 2, or negative 7, or 10, or a half. So there's lots of equations. I'm asking you to find the one general reduced equation that you can get for that kind of answer. Now, so one way to do it is to put in the parentheses. Another way to come up with that same answer is to take the two roots and do the sum of the roots. What's the sum of the roots? 3 plus 5 equals 8. And what's the opposite of the sum? The opposite of the sum is minus 8. Remember here, the opposite of the sum of the roots. And what's the product of the roots? 3 times 5 is 15. So I can write the equation by going x squared minus the sum of the roots times x plus the product of the roots. And I can get an equation that way. So tonight's homework is going to have you find equations using both of those rules. So let's do another one just so to make sure you get what's going on here. So if I tell you the roots are negative 2 and 3, find the equation. Well, what's the sum? Negative 2 plus 3 equals 1. What's the product? Negative 2 times 3, negative 6. What's the equation? X squared minus the sum of the roots plus the product of the roots. There's the equation. What's the other way I could come up with that equation? What would be the parentheses that I start with as the next step? If I had negative 2 as an answer, this would have been x plus 2. What would this one have been? X minus 3. And then I multiply that out. I get x squared minus x plus 6 equals 0. So there are two ways to write the quadratic equation. I want you to be able to do both. This one surely is the easiest, but it's nice to do it both ways because then you can check one way with the other. And that will be what you're doing for the homework. When you get to the second part of the homework, though, they're going to give you some more information. They're going to want you to find the exact equation giving that information. Well, to do that, you need another clue. Because really, this equation is multiplied by some number a. And what is that a? We have to figure out. And it's easy to figure out once you're working the problem. So let's get rid of this stuff. And I'll give you an example of what's going to happen. So a couple examples. You might be given the information here. The maximum value of the equation is 20, and the x-intercepts are 1 and 3. And how do you write the quadratic equation for that? And again, the intercepts are the roots. So you do the sum and the product of the roots. So the sum of the roots, 1 plus 3, 4. Product, 1 times 3 is 3. And then you know that the equation is going to look like this. X squared minus the sum of the roots plus the product. And it's going to equal some f of x. Well, it's going to equal either the maximum or the minimum value. So that means I'm going to do 20 equals, but there's another catch. I need some number a, and I don't know what number that a is at this point. So I have to solve for A in this equation. And so what happens when you have to do that? To do that, we need to think about some information that's given. If the x-intercepts are 1 and 3, and we know we have a quadratic, we have a curve that could go up like this or down like this. Since we're told we have a max of 20, that means the curve goes through these 2 points and up to some maximum of 20, way up here. Suppose these are 2, 4, 6, 8, 10, 2, 4, 6, 8, 20. So suppose that's our 20 mark right there. How do we know some more information about that? Well, that is a clue to a very special ordered pair. The ordered pair has a y value of 20 if the max is 20. So, whenever you're given information in an equation that tells you that you have a maximum point or a minimum point, that point goes here in the ordered pair, the max or the min. All right? It's the high point or the low point of the vertex, and that is a very cool clue to how to find the specific equation that has that ordered pair 1 and 3 as its answer. So, how do I go from there? So I know that the max is 20, right? And I need... So finding the equation for this, we start by setting up, we don't know the A yet, but we know that these intercepts mean that we had x minus 1 and x plus 3, whoops, how about minus 3 there, equal to some number. Well, we know they're equal to the maximum or the minimum, so we have that. And remember we talked about the maximum is part of an ordered pair that has a 20 here. But how do I know what value goes here? Well, remember we talked about the intercepts and where they were on the graph. So if the intercepts are at 1 and 3, and the maximum is somewhere up here, it's ordered pair, even though the second part of it is 20. How do I find that part? I take these two numbers, add them, and divide by 2. 1 plus 3 divided by 2. 4 over 2. That's 2. So that's 2. Now I could find it just by counting. 1, 2. Over 2 up 20. The best way is to take the two intercepts, you add them, divide by 2, and that gives you the other part of the ordered pair. So now I can take this equation and solve it for A, because I knew the 20 went there. Where do you think the 2 goes? It's the x value. So now I do 20 equals A times 2 minus 1 and 2 minus 3. 2 minus 1 is 1, 2 minus 3 is negative 1. So 20 equals A times negative 1, so A equals negative 20. So that's the number that goes there in this particular equation.